Okay, so Claude Code Subagents became even more powerful yesterday because Anthropic added the support for nested subagents. Now, I will actually take credit for this feature because I did say in a tweet, can you allow Claude Code Subagents to spawn up other subagents? And they did like the tweet, so joking aside, basically I want to talk about what exactly this feature means and how you can leverage it to level up your own workflows. Now, just to make sure that we're all on the same page, let's quickly go over why we even need subagents to begin with. So basically, agents like Claude Code really like calling tools, and they will call a lot of tools inside of the main context window. Now, this can be quite bad because as a context window fills up, then it can make worse decisions overall, and we may run out of context. So when it comes time to like editing or running bash commands, it may make worse decisions about what to edit and what edits it should make. But if we delegate everything over here on the left-hand side into a subagent instead, and then tell the subagent to return only the most relevant results back to the main session, then we will get much better outputs because any important decisions happen early on in the context window when it's lean and high signal. So essentially, any kind of noisy tool calling that may or may not return the result that we're looking for can be delegated into a separate context window that can either be thrown away or resumed later. So this can be any kind of really noisy tool calling, like exploring the codebase or searching online, or doing any kind of verification inside of a subagent by using like Claude in Chrome, for example, or another browser MCP tool. Now you will find Claude Code doing this by default, delegating any noisy tool calling to subagent. But now the question becomes, what if this subagent decided that it also needed to delegate noisy tool calling because it was kind of changing up paths or considering another idea? If it did it inside of a subagent's context window, then that subagent could become even noisier and not actually lead to any useful result back for the main conversation. So it would be nice if this subagent could also delegate to another subagent if needs be. So you can kind of imagine it looks like this, what we have so far, the main conversation delegating to a subagent with a tool call. It does a bunch more stuff over here, and then that result is passed back into main conversation. Now, if we take this one step further, it would look kind of like this. So we would have a level 1 subagent, which is one layer deep, and then that may decide, okay, like maybe I should check online whether this library actually makes sense for this project or there's no bug in the library itself. It could then delegate to another subagent that is another layer deep over here to do that task, and then it could continue working whilst that task is in action, and then that result will be passed back into the level 1 subagent once it is complete. And then that is passed back into the main session, so our level 1 subagent will be even clearer in its final result. Now, of course, this can continue and continue up until it's 5 layers deep, and ideally, if you're using a really powerful model that is aware of these capabilities, like the brand new Fable 5 model, then you won't really have to worry about this, because ideally the model will be smart enough to know that it can make these decisions itself. But it may still take a while for the newer models to reach their full potential in being able to use nested subagents. So you may want to manually prompt it or manually override it. Now, it is quickly worth mentioning the Codex app has supported nested subagents for a while because they have a parameter that you can set, which is max depth, and this is default to 1. So for example, if you went over to Codex and then you went over to configuration, open up the config file, and then scroll down. If you add a line kind of like this to your config, underneath agents in Codex, your agents will be able to call other agents inside of themselves. Now, overall, this can be pretty easy to understand, but you may be wondering, okay, what are some practical workflows or use cases here? Now, a lot of people in the replies to the official announcement tweet were also wondering the same thing as well. Now, let's quickly go through some examples so you can get used to thinking in this brand new way. Now, you may have some kind of research flow whereby you have a folder of articles, and you may tell Claude Code, hey, can you like load in all these articles, one per subagent, and then verify all those claims that are made, like the biggest claims inside of the articles. So what would happen is you would have your layer 1 subagent extract claims for like article 1. So this would be loading in article 1, and this would happen inside of a subagent. It would then identify all the claims, and then for each of the claim that is made that it thinks is important enough, it would then like do some noisy searching, either through your knowledge base, searching online or stuff, to actually verify that claim. And of course, whilst this one is running, it would also repeat the same flow in parallel for article 2, article 3, and so forth. So it'll look kind of like this. So you can see that all our noisy tool calling would be separated into layer 2, and layer 1 would just be receiving verifications of all the big claims. Now, one way that you can also have this as a mental model in your mind is that you can have it think about second order effects and then carry on to third order effects and so forth. So let's say you were kind of doing some legal work with Claude Code and you had 10 different contracts, for example. You may have some kind of result that you want from that legal proceeding. And what you can do is you can pass in all those contracts and then have one subagent per contract, consider any implications that would happen to contracts if we were to go for that goal. And then we can have inside of layer 2 subagents measuring the blast radius of if we did change it in that particular way, what else would need to be changed as a result as well. So any kind of noisy searching from previous emails that you may have exchanged back and so forth could be delegated into your layer 2 agent. And if during the noisy searching you wanted to verify a claim by searching online, it could then do that by also delegating to a layer 3 agent. So this would happen for contract 2 and contract 3 and so forth, all in parallel. So we kind of have second order and third order effects being considered here. And by using an approach like this, you may find that for any important work, you uncover more insights than if you just tried to do everything inside of one context window or inside of one agent instead. Now, as for a more technical example, you may have some kind of debugging flow whereby you have a layer 1 agent loading in a brand new instance that just happened. It identifies any potential causes, and then it would fan out and verify a bunch of causes in parallel. So these layer 2 subagents would be searching through the codebase to find any relevant things, and then one of the layer 2 ones may decide to delegate to a layer 3 one to also cross-check with these server logs as well. And you may find that this approach ends up being better because sometimes when it's debugging, it may actually find a problem, but there was actually a deeper underlying problem at play. And if you don't have the right setup, then it may miss out on the deeper underlying problem. So anyway, all of this would collapse back into the main context window, barely have used up the main context window, and then you can fix the issue inside of the main context window again, rather than starting a brand new one. Now, ideally, as the models get better, because the labs improve the reinforcement learning environments with this in mind, we will notice this behavior automatically emerging when needs be, provided you give your coding agent the right goal. But you may not notice this behavior emerging right now because the models haven't reached that level to automatically think, okay, I gotta spawn another agent inside of this agent. In which case, you may want to design your prompts kind of like this, or you may want to design your skills like this as well. Now, if you do like this kind of stuff, then you may want to check out my classes. There is a 30% sale going on right now because I have a brand new class that will be released next week, all about Loopy AI, which is about running AI agents in loops to achieve even better results than you could previously. I have been planning this for the last couple of weeks, and many of the ideas that will be covered, you will not find covered anywhere else on YouTube. Now, people have found many of the things that I teach in these classes to be way ahead of the curve. They learn ideas that often go mainstream many months later. By signing up, you get access to almost 300 videos that I recorded, with brand new videos being added almost every single day. And if for whatever reason you don't like it, there is a 30-day money-back guarantee as well. And if you're part of a team, then there are bulk discounts for team plans as well. And of course, if you do have any questions about this, then you can always email me using the email you can see on the screen right now. Now, one of the features that everyone loves about the class is the fact that you can connect it to Claude Code or Codex using the MCP server, and then it will automatically help you find which videos to watch based on the project you're working on and what you're struggling with as well. Now, another really good use case here is to compare different skills together. So you could load in a whole bunch of skills that do a similar job and then figure out which one is better for your use case. So for example, we could have layer 1 loading in skill number A, and skill number A is designed whereby it will spawn up other subagents to explore the codebase because it's like a code review skill, for example. And then in parallel, we could have another layer 1 subagent loading in skill B, and then that could spawn up their own subagents as well. So for example, you may be checking out the skill, which is Thermonuclear Code Quality Review from the Cursor team. You may install that. And then you may want to compare it against the built-in skill inside of Claude Code for code review. So for example, inside of Claude Code, you could do code review, which is a default built-in code review, do max, and then do Thermonuclear Code Quality Review in separate subagents. Press enter, and then each of them can spawn up their own subagents as well. And then you can say, hey, what results do you think are better? And then Claude Code can give you an honest take by comparing these two skills together. Now, another really interesting thing you can do is iterating on skills. So one paper that I really liked recently is this one by Microsoft last month about skill optimization, whereby you run a auto research to automatically improve the skill prompt and description to try and get even better results from those skills. And this can be really handy for skills that you run on a daily basis because you want to make sure that they are as good as they can be. So one way that you can do this is you could have the subagent load in the first version of the skill, and then that would spawn up a whole bunch of new subagents that may be doing some kind of code review or something. And then Claude Code is like, okay, let's try and see if we get different results by editing that skill. So that means Claude Code can then write a version 2 of the skill, and then it would run that, and it may go overnight or something, and then find a really good skill that leads to consistently good results after 9 versions, for example. And because of course you're using that particular skill every single day, you may find that to be a really good use of your tokens. So because Codex supported nested subagents first, I had a folder called Skill Optimization, and I optimized one of my favorite skills, which is the Spec Developer skill by the Claude Code team. So this is one of the skills that interviews you about a bunch of things, and I found this to be better than all the other skills out there. And basically, I was wondering to myself, okay, could I make this even better? So I gave it over to Codex at the very beginning, I set a goal, and then I just had it continue with the help of nested subagents, and it gave me a pretty good final skill that I found performing better than the previous one, that I'm basically calling Spec Developer Enhanced. Now with the brand new Fable 5 model and nested subagents, I will be enhancing more of my own skills and then slowly sharing it on my GitHub over the coming weeks. So if you want to check that out, that will be linked down below. And if you do want to stay in the loop of what I'm doing and learning, then I also have a free newsletter that will be linked down below. And by signing up, you get access to many free videos from the class as well.